So this section is the last section in chapter 9, if I remember right. It should be. It's about hyperbolas. So we've already worked with some hyperbolas, right? But like everything, we're looking at a specific type of hyperbola. So we're going to be dealing with hyperbolas with asymptotes of y equals x and y equals kx. Or sorry, negative x. So let me try that one again. Yep. So this is going to be a special type of hyperbola where they're going to be branched either down the y-axis or down the x-axis, like everything else we've been doing with the parabolas or the ellipses. Okay? So in general, this is what your hyperbolas are going to look like. Okay? You have a vertex here and here that the hyperbola will pass through. You have a focus, just like always, because you have a curve, right? And then as far as the spread of your asymptotes here, they're going to be determined by the b value. Okay, so if you notice, the b value is the distance from the transverse axis to this point, right, in both directions, and it has to pass through the vertex. So your the coordinates to your asymptote here are actually going to be a, b. So, well, this one's negative ab. This one is a, b. Everybody okay with that? And then down here it'll be negative a, negative b, and a, negative b. So the a and b actually determine where the asymptotes go, as well as where the vertices go, and the foci. Everybody okay with that? Yes, no, maybe? So it's like anything, let's get into using it. So here's your two sets of equations, so please get these copied down. And there's a few particulars that I want to point out. All right, so I know you're still working, but if you notice, right, we have subtraction signs this time between the fractions, okay? And one of the other big things is you notice that the a squared is in the exact same position for both equation types, right? So what we use in this position to determine whether it's a vertical or a horizontal hyperbola is what variable is in the lead, right? Because order matters in subtraction. So do I have an x squared minus a y squared, or do I have a y squared minus an x squared? Okay? So that's going to determine whether it's horizontal or vertical for the transaxis. Everybody okay with that? Okay, so if you notice, what are both equations equal to? 1, just like for an ellipse, right? But instead of it being addition, it's subtraction. Okay? All right, your vertices are still at a, right? If you notice for your asymptotes, right, they're going to be at b over a and a over b. And then your foci are still at plus or minus c0, 0 plus or minus c. But if you notice, the formula for foci is shifted, right? For an ellipse, it's c squared equals a squared minus b squared. For a hyperbola, it's c squared equals a squared plus b squared. So please make sure you get that copied down, all right, because that did change. Everybody good? Yes, no, maybe? So we're going to start these off the exact same way. Okay, we're going to find our vertices. We're going to find our foci. We're going to find our asymptotes, and then graph everything and just connect the dots. Okay? So any major, gigantic, holy snot questions with this, or is this stuff starting to kind of fit together a little bit? Okay. Because vertices are always vertices, foci are always foci, right? All right. So if I gave you this equation and I said, I want you to graph it, what's the first thing you recognize? What's the first thing you notice? What's the first thing you see? Okay, it's not equal to 1. And is it an addition or a subtraction? It's a subtraction, right? So is this going to be an ellipse or a hyperbola? Hyperbola, because it's a subtraction, right? So since I recognize that it's going to be a hyperbola because it's a minus, and hyperbolas are the only subtraction we have, right? So out of parabolas, circles, ellipses, hyperbolas are the only ones that are allowed to have a subtraction. I have to make this thing equal 1. So how do I make it equal 1? Divide by what? Okay, divide by 100. And that gets me a y squared over 4 minus an x squared over 25 equals 1. So just like always, I'm going to need to find my a, my b, and my c. And then I'm going to need vertex, foci, asymptotes. So first things first, what's my A going to be? So in this situation, if you look at both equations, right, is A in the the denominator for the first fraction or denominator for the second fraction? A is always the first fraction, right? So what's my denominator here? 4. So this is A squared. So what's my A? 2. Everybody okay with where that's coming from, yes or no? So for ellipses, the bigger number is A, right? For a hyperbola, the first denominator is A. All right, so it's a little bit different in here. So you have to pay really close attention as to whether it's a minus or a plus. Okay, and that's why I have you write down the formulas so that you can see it. Okay, so if you're not sure, reference back to those, because remember on the quizzes and tests you get that formula sheet where this is all explained. So make sure that you understand the subtle differences here. All right, so which piece is my B squared? The 25, and what's the square root of that? Okay. Now how do I find C? So what's the equation for the foci? Okay, C squared equals A squared plus B squared. So what's 4 plus 25? 29. So C is going to be plus or minus the square root of 29. And what is that going to be? Plus or minus 5 point what? All right, was there a 6 after the 1? Okay, so it's 5, 2. All right, everybody okay with that? Yes, no, maybe? Okay. So which variable do I have in the lead, X or Y? Y. So am I using the top equation or the bottom equation? The bottom. So for the bottom, is my vertex going to be 0A or A0? 0A. So what's my A value? So I get 0 plus or minus 2, right? The foci are going to match. So if I have a 0 in the lead here, I'm going to have a 0 in the lead there. And because I don't have a lot of room, I'm going to write it as the square root of 29. Okay? But I'm going to use the 5.3 and 5.2 when I actually graph. Everybody all right with that? Okay. For my asymptotes, are my asymptotes plus or minus A over B or a plus or minus B over A? A over B. So what's my A? And what's my B? So I get 2 over 5x. Any major gigantic questions on that? Yes or no? So all I'm doing is exactly what the formula tells me to do, right? And again, what's the hard part? Making sure that you're matching up and using the right formula. Okay, so I see a subtraction here with a y squared in the front. That tells me which of my equations to use. Everybody good? Yes? No? All right. So I'm going to start off with my asymptotes. So what kind of lines do we use for asymptotes? Dashed lines, always. So y equals plus or minus 2/5 x, right? So if I just look at this as plus 2/5 x, right? What's the b up here? What's the y-intercept? 0, and what's my slope? 2 over 5. So I'm going to start at 0, go up 2 over 5. 1, 2, 3, 4, 5. So I have to pass. Whoops, I missed. So there's my one asymptote. Everybody okay with that? Yeah? There we go. All right. So I pass through 0, 0, right, because that's my b, and then I just use my slope of 2/5, go up 2 over 5. Right? Put in a dashed line. Everybody okay with my asymptote? All right, so now I'm going to look at the negative side of this, right? My slope for the second piece is negative 2/5. So I'm still passing through 0, 0, but instead I go up 2, 5 to the left. Or you can think of it as down 2, 5 to the right. Yes, because my b is 0. Using my slope, graphing these lines, positive 2/5 x plus 0, and negative 2/5 x plus 0. So I start at 0, go up 2, 5 to the right, put in a dashed line. So that's my first asymptote. Start at 0, use a negative 2/5 slope, so I go up 2, 5 to the left, and put in another dashed line, and that'll be my second asymptote. So the whole point behind this is, remember, your graph has to fit somewhere between the asymptotes, right? It's either going to be a branch up here and a branch down here, or it's going to be a branch on the left vertical edge and then on the right vertical edge. Okay? So it depends on whether the graph is going to point up and down or if it's pointing left and right. But the asymptotes always determine the shape of the graph. How big are the branches? How wide do they spread? That's always determined by the asymptotes. Everybody okay? Yes, no? All right, so now I'm going to plot my vertices. So where's my vertex? Where's my first vertex at? 0, what? 2. And 0, negative 2. Everybody okay? Yes, no? So is my hyperbola going to be Pointing up and down or pointing left and right? Up and down, right? So I'm going to have one branch up here and one branch down here. Everybody good with that? Yeah? All right, so where are my foci at? what was it? 5.3852? 1, 2, 3, 4, 5.38. So again, label everything. Focus. Vertex. Asymptote. So real quick, is this an asymptote type that we've talked about before? What are the only two types of asymptotes that we've discussed? Vertical and horizontal. Okay, these are called slant asymptotes, and they do show up quite a bit, okay? This is the most basic form of where they show up, but if you fit that form of an equation, right, where we're used to seeing if x is in the denominator, then we're going to get a hyperbola. But this is another form of hyperbolas, and these are the ones where you get slant asymptotes all the time. Okay? So where is my graph pointing? Up and down, right? So I just start here, curl it out, right? Can I cross over an asymptote? No. Nope. I want general shapes. I want sketches. Because what I'm going to be grading you on is all of this. Okay, so if you look at it by points, we have 1, 2, 3, 4, 5, 6 points here, right? And I have 1, 2, 3 points on the graph. All right, so these are worth like 10 points, 3 points inside, 7 points outside. Okay, so this is what I'm really going to focus on is this stuff. Everybody okay with that? Yeah? No, maybe? Yeah. Okay, good. I got one of you. Everybody else good too? All right. So just like before, I'm going to also ask you to find the equation given a certain situation. So for this situation, we have a vertex and a focus. And it's just like everything else we've done. All right, so the vertex is -3, 0. The focus is 4, 0. All right. So before I pick, right, they told me that this is a hyperbola. And again, it being centered at 0, 0 just means that we can use our formulas, right? So I need to figure out which variable goes where, right? So what I do is I look at my vertex. Is my vertex x squared in the lead or y squared? Who knows? So is my vertex a number 0 or 0 number? It's number 0, so is it x squared or y squared at first? X squared. And then y squared. Okay, what always goes under the lead piece, A or B? A, and where does A come from? The vertex. So this is -3, 0. Oh, whoa, sorry. -3 squared. And then what number do I still have to find? My B. All right. So I'm going to use my focus for that. So again, what's the formula for focus? Okay, plug in what you know. 4 squared equals -3 squared plus B squared, right? 16 equals 9 plus B squared. B squared equals 7. Everybody okay with that? Yeah. 16 minus 9, right? So that means that B equals plus or minus the square root of 7. Any questions on that? All right, so let me throw this in here. What's -3 squared? 9, right? What's the square root of 7 squared? So here's your equation. And that's it, you're done. Any questions on how I did any of that, how I found any of it? Anything at all kicking up like, I'm not sure. Because we square rooted a number, so we got a plus or minus, but it doesn't matter in our final result because a positive squared is positive and a negative squared is positive, so it looks like it goes away. I won't mark you down for it, no. I just want to keep it consistent because when you do find a focus like we did over here, we do have to write it down as a plus or minus inside the foci mark. Okay. All right, so everybody okay with that? Yes, no, maybe? So it should look like everything else we've done, right? So like I told you, Chapter 9 is nothing but formulas, and it's all about picking the right one and making sure that you know how to use each of them. All right, everybody good? Yeah? All right, then here's your homework. I do want to talk about 27 through 32 a little bit. All right, I want you to identify what conic section the equation represents, which means is it a parabola, a circle, an ellipse, or a hyperbola? Everybody okay with that? And then what I want you to do is find the information needed to graph it. So what I mean is if it's a parabola, mark it as a parabola, find me the focus, the directrix, the axis of symmetry. Everybody okay with that? If it's a circle, mark it as a circle, find me the center and the radius. If it's a hyperbola, mark it as a hyperbola, find me the vertex, the foci, the asymptotes. If it's an ellipse, right, find the vertices, the co-vertices, the foci. Everybody okay with that? So you don't have to actually graph it, but I want you to find the points that you would use in order to graph it. Because again, that's what I really stress. All right, and if I remember right, this is the end of the chapter, so I want to make sure that we're still getting all of the stuff we've already covered. Yeah, yep. What shape does it make?